So pretty much every digital logic lab that we're going to do is going to involve integrated circuits, or chips, ICs as they're called. When you put an IC into the board, there are two ways to know that you're doing it correctly. One of them is that there's always going to be a notch on one side, and that notch needs to go on the left. It always goes on the left. The other way to note it is that if you can read the writing, and hopefully you can, if you can read the writing, it should always be in the correct direction facing you. So when I put this into the board, remember that what I need to do is not put it up here, because if I put it up here, then say the top pin over here and the bottom pin over here, they'll be connected to each other, and I don't want that. So instead what I'm going to do is I'm going to straddle the midpoint here. So when I straddle that midpoint, that means that I have direct and unique access to all of the pins of this chip. Now most of the chips that we're going to be working with have 14 pins. I'm going to go ahead and put this in. Sometimes, by the way, it helps to insert one side, so you can sort of see that I'm kind of rocking this in to put the ones near me in first, and then I push it into the other ones. So just double check, once it's inserted, double check that you haven't bent any of the pins. You want to be careful about that. It's an important thing to observe about these integrated circuits is that there is a particular numbering pattern that is to be used. So I'm going to zoom in on the chip here so that you can see the numbering pattern. When the chip is facing you, notice that the pin on the bottom left corner, that'll be known as pin number 1. And then here's pin number 2, 3, 4, 5, 6, and 7. So most of our chips will have 14 pins, 7 on the bottom. Then we wrap around, and this is a little bit surprising, but this is pin 8, pin 9, 10, 11, 12, 13, and 14. So the numbering pattern goes like this. It goes from the bottom left, it goes around the top, and then back to the left. So this is pin 1, pin 7, pin 8, and then over here is pin 14. That's important because the pinout diagrams that you're going to have reference the pins by number. And this is probably not the numbering system that I would have chosen, but it is the numbering system that has been chosen. And so we need to use the numbering system since we're going to be using those pinouts. Now, one thing to know about these chips is that every one of them is going to need to have power and ground connected to it. And so to be able to perform its function, it's going to need to have a connection to ground and a connection to power. Now, the connection to ground is nearly always going to be pin 7. You're going to want to check the pinout for your particular chip just to be sure, but I can tell you that for all the chips that we're going to use in the lab this week, pin 7 is definitely going to be the ground connection. So there's the ground connection. That's all that you need to do to that one. And then the power connection, that's typically going to be pin 14. And so up here, you can see that I've got pin 14, and there's a power connection. Whoops, didn't quite get that wire in there correctly. Sometimes this takes a little bit of extra effort. So there's pin 14 connected to power. So it takes maybe 10-15 seconds to connect put the chip into the breadboard, connect the ground, connect the power, and now you're ready to begin to use. I would probably use these hookup wires. I think that these are a lot easier to be able to push in and quickly and easily pull them back out again, put them here. You'll be connecting these chips, these pins on this chip to other pins on other chips. And so it's nice to have the ground and power nice and tight to the board here, but then these, you want to have them be kind of big and looping so that when you're done with a particular circuit, you can just easily pull them out, leaving behind the ground and power that definitely is going to need to remain. One other thing I wanted to mention about integrated circuits before we wrap up here is that you need to be careful when removing these chips from the board. Now, you're not going to need to probably remove them from the board today, but when you do, be careful not to just use your fingers, because I've done this many times. Talk to every professor, they've done it too. You reach in, you pull the chip out, and what happens is one end will come loose, and that end will stick the pins under your fingernail, and it is really, really painful. So there are two correct ways to remove an integrated circuit from the board. One of them is just to use a pair of needle nose pliers. You can probably spread the pliers barely far enough apart to get them around the integrated circuit and then just pull it out. I intentionally didn't pull it out there because I wanted to show you the better way, and that is a chip puller, an integrated circuit puller. This is a tool that is specifically designed for exactly this task. So you simply reach underneath the integrated circuit here. I'll try to make this so that you can see it better. You reach under the integrated circuit and it just pulls right out. And you never jam it under your fingernails, and you never hate integrated circuits as much as I do, because they will never hurt you as much as they did me.